Hello YouTube, I'm gonna try and make some theoretical videos, starting with grit. Sorry for my bad writing, but grit in sharpening stones. Let's start with shapes. Some grit can be round, some can be square, some can be oval, some can be triangular, more and less pointy, etc, etc. And that affects the stone. Let's say all we are talking about here is, for example, 1000 grit stone. Then 1000 grit stone with more circular, more round, abrasive will not be as harsh, aggressive, fast, or create as deep scratches as one with sharper, more triangular, more pointy abrasive. Given the same abrasive, given the same hardness, same grit size, etc. Just talking about shapes now, then this will dig deeper than this. The more circular round shapes will be gentler on the edge than the more square or more triangular pointy ones. And then you have durability and break off of the abrasive. Here I'm going about 50% of the abrasive poking out the binder. It will be less chance for more circular abrasive to be torn off the stone than triangular, because here the peak will grab more and put more shear force on the top of the abrasive. And that also has a big correlation with shapes and how they are put in the binder. These are supposed to be all the same size abrasive. Let's say again it's 600 grit. I can do it like this. 600. But imagine the same size particles, but in a binder that nearly all the abrasive is pointing out. So here's the binder. Can you get me? This line is the binder and this is pointing out. That's a huge amount compared to if half the abrasive is poking out, or maybe 3/4, or maybe 4/5, for example, or just one tiny part is poking out. That's determined by the binder. If this was a diamond plate, how much nickel plating, in a wet stone or resin stone, how much binder is and how the abrasive is mixed in. And now let's imagine you have some that is that much poking out, you have some of them, you have some of them, you have everything here is a huge mix. It's still 600 stone, but let's imagine one stone is with that type of circle of abrasive and is maybe poking out that much. Still 600, because that's determined by the grit size, not the shape and not the amount of the abrasive poking out. Let's take still a 600 grit stone, but the most pointy ones. And let's imagine it's nearly all pointing out. You will get two completely different stone. One will shed metal, one will barely do anything and act much finer, even though both is 600s, and they will react different to different pressure and such. That's why some stones, if you use pressure, they shed abrasive because it's breaking off, or the binder is too soft. So yeah, this is a huge complex topic, but that is as easy as I can try and explain this. Now, and I'm not taking contrast versus aluminum oxide to silicon carbides to diamond to cubic board nitrate to natural abrasives like corticules or J-nuts, etc. Let's put all that away because it's all here. So it's just hardness from the abrasive. Either it cuts or it doesn't cut. I'm not going into sharing carbides and hard performance seals, etc. here now, because most normal knives can be cut by most normal stones. But now let's take metal hardness into account. If I have a damn hard knife, let's say I use the same amount of force on all these here. This will represent 4 different knives. One knife is, let's say, 65 HRC. Maybe if I use 1 kilo of force, 1 kg, or that's 2 pounds, around there. Let's say with the 65, I get this deep in the abrasive. That's barely not doing anything, so with that hard knife I need more force. Let's say I get a knife that is 61 HRC. That's a huge amount of difference, because HRC isn't linear. That would be a different topic. Just bear with me, then maybe that will go that deep. That's 3-4 times as deep. Let's say I got a pretty soft knife. Let's say the standard industry is around 58. And with all the same force, now maybe I'm tearing down here. That's why on softer knives you often see stones shedding abrasive, because we're using the same amount of force here, and that doesn't add up, because the softer steel will grab more abrasive here and tear it up, while the harder steels will skate more. Now let's take soft steels like 54, 55 HRC. Yes, I'm dyslexic and I have bad writing. Those will maybe just tear into the whole abrasive if we use the same force as the harder ones. So your force also, imagine if you are hitting the entire abrasive into the knife versus just that part. So force will also make a 600 grit stone like finer with less force, or harder steel it will be finer. Softer steel or more pressure will make it coarser. It's still the same grit. Then how much binder is on will change how aggressive or coarse it is. The durability and break off will change that, and the shapes. So what does that tells us? Simplified is the number doesn't matter as much in real world application as the shapes, the break of the binder height, the hardness of the abrasive, the hardness of the steels. That's why some get terrific results of one stone but not another stone in the same grit range. So that's also why it's hard to recommend and say this works on this or this or this, because if you ask me what works on a soft Victorinox or Global, that will be a whole different stone than what works on Rex 121, for example, which you need diamond or cubic boron nitride or similar, or silicon carbides, abrasives, etc. But this is just scratching the surface here, because as said, steel impacts how deep you go into it, the stone, pressure, hardness, how much binder or abrasive is poking out. You can even argue if the abrasive is laying that way or that way. So when let's say it's pointing this way, I go into it, I will grab it, but if I go that way, I will skate more over it, and you get my drift. So, stones are complex, and most likely if you get a harder knife, 600 will act more like a 800. If you got a really soft knife, it will act more like a 400 or so, and it will still be a 600 abrasive size. Remember, grit is the size of the abrasive, not how it impacts the steel. So yeah, I hope this video helps. Leave comments, ask, and I'll try to answer. And no, I'm not educated in this, but I've read about stuff. I've been using knives and stones for around 20 years, and I'm really passionate about this. This is the first vid in my series. The other will go more into steel and knife geometry. Thank you. Bye.